Hey everyone, welcome to question 4 from the chapter 6 review. So again, we're provided the graph of a trigonometric function and we want to write an equation for the graph shown. So in this case, we can kind of see that it must be a reciprocal of either sine or cosine. So what I would suggest doing is kind of running through and maybe sketching in a dashed line to see which function this might be connected to. So as I'm looking at this, I'm noticing a couple things. So one of which is that where the starting point is on the vertical axis. It looks like if you're looking at the dashed sinusoidal function that we have graphed, it's starting at the top and not through the center of our midline. So I'm assuming that this must be the reciprocal of cosine. So in other words, we're looking at a secant function. So what I want to note here is we're going to go ahead and still identify what's my midline. So looking at this, it looks like my midline is happening at -1, or it's cutting through -1 on the vertical axis. And again, if you want to kind of justify that, we could say, well, my maximum looks like it's starting at a +1, and then it looks like my minimum starts at a -3, and we want to divide that by 2, because essentially what we're doing is we're taking the average or finding the middle line. So in this case, we would get -2/2, which takes us to that -1. The next thing that we would want to do is note the amplitude. So from our midline, it looks like I traveled from -1 up to +1. So my amplitude is 2. Again, refrain from believing that refrain from having to ask yourself the question, is this positive or is this negative? Because amplitude is connected to radius, and radius measures a distance, so therefore it cannot be negative. So the next thing that we want to note here is the period. So it looks like, in terms of the period, if I were to kind of sketch in some vertical asymptotes to help me out here. I'm just going to do enough so that I can follow along. It looks like from here to here is where I have a unique sketch of the graph. So after that, everything begins to repeat itself again. So it looks like I'm going from -5 to -1. So my period here is going to be 4. So again, this is beneficial for us because now we can take this information and we can locate or determine what the horizontal stretch or compression is, because we know that that is going to be 2 pi, because again, the period of a secant function is still 2 pi, and we're going to divide that by the period. So if we put that in, we have 2 pi all over 4, so this simplifies down to pi halves. So now we're ready to assemble everything. So what we want to note here is we'll still have f of x. We know that there will be an amplitude. We now know that we're dealing with a secant function. We will have our horizontal stretch or compression, and then we have x minus h to indicate if we had any kind of horizontal shift. In this case, since it looks like we're starting on the vertical axis, it doesn't look like we will have a horizontal shift in this case. The only way that that would happen would be if we decided that we wanted to write this as a cosecant instead. So, and then we will add in our midline. All right, so let me just clean up any stray marks so that we can kind of look at this the screen as neatly as possible. And essentially, once you get to this part, and if you feel okay, then this is just a matter of putting everything in order. So here we know that our amplitude will be 2. Our horizontal stretch in this case will be pi halves. We don't have a horizontal shift, so I'm just going to leave that as pi halves times x, and then we have a midline of -1. So here is our solution. Okay, if you do have any other questions, please let me know.